If you could spend one day in the year 2100, what would you find? A world subtly or radically altered by technology and climate, yet recognizably human. But this is a mere blink of an eye. The true drama of existence unfolds on a timescale that dwarfs human history. A future measured not in centuries, but in eons. What if you could see 1,000,000 or even 1,000,000,000 years into the future? What cosmic events await? And what will become of our legacy in the vast, silent universe? Let's begin our journey on Earth with a scar of our own making. In 22,000 AD, the Chernobyl exclusion zone may finally be safe for permanent human settlement. The half-life of plutonium-239, a key contaminant, is a staggering 24,100 years. This single disaster serves as a chilling monument to our species, capacity for error, an atomic ghost that will haunt our planet for a duration longer than all of recorded history. It forces us to confront a profound question. How do we warn future civilizations of the dangers we've buried, when languages and cultures may be utterly alien? By 50,000 years from now, a more subtle, cosmic process will make itself known. Due to the relentless gravitational tug of the moon, which creates the ocean tides, Earth's rotation will have slowed enough to make our day 1 full second longer. This gradual lengthening, about 1.8 milliseconds per century, seems insignificant, but over geological time it reveals a fundamental truth. Even the bedrock constants of our daily experience are transient. A future civilization would face the bizarre choice of adding a leap second every single day, or fundamentally redefining the measure of a day itself. Look up at the night sky in 100,000 years and you will see a celestial map rendered unrecognizable. Due to the proper motion of stars, Earth's journey around the galaxy will have completely rearranged the familiar constellations. Polaris will have long abandoned its post as the North Star. The myths and stories humanity has written into the heavens will be erased. A cosmic etch, a sketch shaken clean. Perhaps, by then, humanity will be watching this alien sky from a new home. Mars, if terraforming efforts succeed, could be a second cradle for life. But the move may not be a choice, but a necessity. In 500,000 years, it is a statistical near certainty that Earth will be struck by an asteroid over a kilometer in diameter. For perspective, the Chicxulub impactor that eradicated the dinosaurs was roughly 10 kilometers wide. A 1-kilometer object is smaller, but still a civilization-ending event, capable of carving a 400-kilometer crater and triggering global firestorms that would render the atmosphere unbreathable. Our existence hinges on a cosmic lottery we are destined to eventually lose. If an asteroid doesn't seal our fate, the planet itself might. Within 1,000,000 years, Earth is likely to experience a supervolcanic eruption on a scale that dwarfs any modern event. The last comparable cataclysm, the Toba eruption 74,000 years ago, ejected over 3,000 cubic kilometers of magma, enough to fill 75% of the Grand Canyon, and plunged the world into a volcanic winter lasting a decade. Scientists theorize this event created a genetic bottleneck, reducing the entire human population to just 3,000 minus 10,000 individuals. We are all descendants of apocalypse survivors. Yet, if humanity navigates these terrestrial and cosmic threats, what could we become in 1,000,000 years? According to the Kardashev scale, we might ascend to a Type 3 civilization, harnessing the energy output of the entire Milky Way galaxy. Such a civilization would command technologies bordering on magic, constructing Dyson spheres around stars, manipulating space-time, perhaps even existing beyond conventional dimensions. But this raises a sobering philosophical question. Can a species that evolved through conflict and still struggles with tribalism be trusted with the power of gods? Or would we become the very galactic threat we now fear? The solar system itself is not static. In 50 million years, the orbit of Mars's tiny moon, Phobos, will decay. It will cross the Roche limit, the point at which tidal forces overwhelm gravity, and be shredded into a spectacular ring system around the red planet. Yet, even rings are ephemeral. In 100 million years, Saturn's iconic rings will be gone. Pulled in by the planet's gravity as ring rain or ejected into space, they will vanish, leaving the gas giant unadorned. In 240 million years, our solar system will complete one full orbit around the galactic center, a single galactic year. The last time we were in this position, dinosaurs were first taking hold on the supercontinent of Pangea, and history will rhyme. In 250 million years, plate tectonics will have reassembled the continents into a new supercontinent, Pangea Ultima. Its vast interior would be an arid, inhospitable desert, forcing life into a competitive coastal fringe and driving evolution in unpredictable new directions. By the 500 million year mark, a far deadlier threat looms, a nearby gamma-ray burst, GRB, forged in the heart of a collapsing hypergiant star or a neutron-star collision. A GRB unleashes more energy in seconds than our Sun will in its entire 10 billion year lifespan. A burst within 500 light-years would be catastrophic. Its high-energy photons would rip nitrogen molecules in our atmosphere apart, creating nitrogen oxides that would catalytically annihilate up to half the ozone layer. The raw UV radiation would trigger mass extinctions on land and in the sea. It is the universe's ultimate sterilizing beam, a reminder of its profound indifference to life. And this heralds the beginning of the end for our blue marble. By 800 million years, the Sun's slowly increasing luminosity will have accelerated the weathering of silicate rocks on Earth, a process that pulls CO2 from the atmosphere. Carbon dioxide levels will plummet to a point where photosynthesis is no longer possible for most plants. The great oxygen-producing engine of the planet will sputter and die. Without oxygen, multicellular life is doomed. Earth will revert to its primordial state, a barren, searing wasteland inhabited only by the hardiest single-celled organisms in the deep dark, its surface sterilized. Faced with this inevitable, silent end, what is the meaning of our fleeting existence? Perhaps the answer lies with Voyager. In 1977, NASA launched 2 probes into the cosmic ocean, each carrying a golden record. This message in a bottle contains images, greetings in 55 languages, and music. It is our attempt to say, "We were here." Of all the tracks, the most poignant is "Dark Was the Night, Cold Was the Ground" by Blind Willie Johnson. A man blinded as a child, who lived and died in poverty, his life poorly documented. Yet his art, a wordless, mournful slide guitar lament, travels the void at over 17 kilometers per second. It carries the weight of the human condition, our suffering, our loneliness, our profound yearning for connection in the dark. Astronomer Carl Sagan, who led the project, understood this. He chose the song because it speaks a universal truth about struggle and hope. The Golden Record is not a monument to our power or intelligence, but to our vulnerability. The image of Blind Willie Johnson, a man we barely know, becomes a snapshot of all of us. Creatures born on a pale blue dot, briefly lighting a candle against an overwhelming darkness, and sending a spark of our soul out into the eternal night. That spark may be the last and most honest thing the universe ever knows of us.